On to our last section, 6.5. It's on page 461. The first two review problems I'll do are 21 and 24. They are just asking you to simplify the given expression. So the identities you're going to want to know for this, it's mostly going to be like a Pythagorean identity is going to be the most common thread, but you'll also need to know just general algebra expressions and how to reduce algebraic expressions. So in 21, you start with cosine squared plus 4 cosine plus 4. And that's all over cosine t plus 2. Now, when you go to look at this, if I just turn my cosine squared t into, well, it's called substitution, I guess. We haven't talked much on it, so it's more the method than the exact process we're going to go through in 21. But in general, keeping in mind that you can write u, the variable u, as cosine of t. So here we have u squared, cosine squared. Here we have our u, and here we have our constant. So if you rewrite the top in terms of u, what you end up with is u squared plus 4u plus 4 all over u plus 2. Alright, so now that we have that, looks a lot more algebraic. Shouldn't be as intimidating. So if you factor the top, u squared plus 4u plus 4 is really just u plus 2 times u plus 2 if you want to look at it that way. Or you could look at it as u plus 2 quantity squared. And that's all over u plus 2. Alright, so we've got one of our u plus 2's cancel. We're left with u plus 2 as our expression. Well, we can't just leave it as u plus 2. We need to go back and substitute u as cosine. So your final answer is u was cosine of t plus 2. Can't reduce any further than that, so you're done on 21. So on to 24, I believe it is, 24. Let's start a new page. Here we go, 24. Looks like this. We have 1 plus tangent squared. Oh, I'm sorry, made a mistake there. It's 1 minus on the top and then 1 plus tangent squared on the bottom. And to that we add 2 sine squared. Okay, so again, one rule you can always follow, is turning your tangents into sines and cosines. Turn everything into sines and cosines. So what we end up here is 1 minus sine squared over cosine. Okay. There. Over cosine squared. 1 plus sine squared over cosine squared. I'll just continue it. Plus 2 sine squared. Now sine, you have 1 minus sine squared over cosine squared. We need to get that. In my thinking, I'm looking at that as two fractions, even though 1 is really a whole number. I'm going to go ahead and turn that into a fraction. So if I go back, write it as 1 over 1. Now we have two fractions, we need common denominators. So in order to get that, our next step would be 1 over 1 we need to multiply by cosine squared. Minus, sorry, it's getting a little messy, sine squared t all over cosine squared. So our top has now, we've taken one fraction, 1 over 1, and the other fraction sine squared over cosine squared. We've put that into one fraction common denominator of cosine squared. So we'll do that on the bottom as well. Of cosine squared plus sine squared over cosine squared t. There we go. Now, let me use kind of a bright color. Here we have an identity, cosine squared plus sine squared. Sorry, I need to keep that going. So I'm going to bring this back up to the top of our page. So cosine squared minus sine squared is not an identity. However, cosine squared plus sine squared is just 1. So it's 1 over cosine squared plus 2 sine squared. Now here we have a fraction on top divided by a fraction on bottom, and I'm going to rewrite that. So we have cosine squared minus sine squared over cosine squared. Now instead of dividing by 1 over cosine squared, I'm going to multiply by the reciprocal of cosine squared over 1 over 2 sine squared t. I'll show the cancellation. Cosine squareds cancel. So we're left with cosine squared t minus sine squared t plus 2 sine squared t. And if you look at, I'll highlight it again in, so negative sine squared plus 2 sine squared gives us just 1 sine squared. So we're left with cosine squared t, negative 1 sine squared plus 2 sine squared gives us plus sine squared. And we are back again to the Pythagorean identity. Cosine squared t plus sine squared t is 1. And we have our reduction. So 1 over tan squared, I'm sorry, 1 minus tan squared over 1 plus tan squared plus 2 sine squared, this whole first equation is really just representing the number 1. So that is how you do a problem such as that with the reducing using identities.